The Ordovician seafloor was not a quiet place. It was crowded, unstable, and increasingly dangerous. Predators moved above the mud, soft sediment shifted beneath it, and trilobites lived in the narrow space between hiding, sensing, and being eaten. In that world, their bodies changed in extreme ways. Some became buried watchtowers, others became armored traps, sensory platforms, or giants moving across the seabed. This is the Ordovician world, where trilobites became almost unrecognizable. The Ordovician period, between 485 and 443 million years ago, was one of the most extraordinary chapters in the history of life. Long before giant dinosaurs or mammals appeared, Earth's oceans were already crowded with bizarre and highly specialized creatures. Among the undisputed rulers of these ancient seafloors were the trilobites, marine arthropods that had already existed for millions of years, but now expanded into an astonishing diversity during the Great Ordovician Biodiversification event. The seas of the Ordovician became a world of escalating pressure. Predators were becoming faster, larger, and more efficient, especially the terrifying straight-shelled nautiloid cephalopods that cruise through the water like living spears. Against this backdrop, trilobites developed some of the most extreme anatomies ever seen among marine arthropods. Some of the strangest changes appeared in their eyes. One of the clearest examples was Asaphus kowalewski, discovered in Middle Ordovician deposits near St. Petersburg in Russia. At first glance, it looks almost unreal. Its eyes rose high above the sediment on narrow stalks. So strange that Asaphus has even been compared to Jar Jar Binks from Star Wars. These eye stalks could reach more than an inch in length. Paleontologists believe Asaphus likely spent much of its life half buried in soft sediment, hidden from danger, while only its eyes protruded above the mud like biological periscopes. From that concealed position, it could scan the surrounding seafloor for approaching predators without exposing the rest of its body. Other trilobites took vision in a very different direction. Members of the genus Cyclopyge evolved some of the largest eyes known in any trilobite. Their enormous bulbous compound eyes dominated nearly the entire head, and in some species, the eyes almost touched at the center. These animals inhabited the dim, mesopelagic twilight zones of the ocean, where sunlight barely penetrated the water. In that shadowy environment, every fragment of light mattered. Their gigantic eyes acted like deep-sea sensors, gathering the faintest rays, filtering down from the surface above. But not every trilobite depended on sight. Some lived on or within unstable seafloor sediments, where touch, vibration, and chemical signals may have mattered more than vision. Trinucleus and Cryptolithus, common in Ordovician rocks such as those of Wales, possessed broad flattened head shields perforated by intricate rows of tiny pits, arranged in honeycomb-like patterns. Their appearance was deeply unusual, almost resembling living sieves resting on the seabed. Scientists still debate the purpose of this structure. It may have helped in filter feeding, trapping microscopic food particles drifting through the sediment. It may also have functioned as a sensory surface, detecting subtle vibrations in cloudy waters where sight was less useful. Whatever its exact function, it shows how far trilobite anatomy could diverge under different ecological pressures. Closely related to these forms were the astonishing harpids, often grouped under harpides. These trilobites looked unlike almost anything alive today. Their crescent-shaped bodies carried massive horseshoe-like head shields, bordered by delicate thread-like spines. These extensions likely helped spread the animal's weight across soft sediment, preventing it from sinking into unstable seafloor mud. At the same time, the broad structure may also have helped sift edible organic particles from the substrate beneath them. A similar logic appears in Dionide, another trilobite with one of the strangest head shields of the Ordovician. Its cephalon was hyper-flattened and covered in a delicate meshwork of pits and ridges. Much like a snowshoe, this broad structure distributed the animal's weight across soft sediment. Yet the fine textures may also have housed specialized sensory organs, turning the head into a wide environmental detector capable of reading subtle chemical or mechanical signals from the seafloor. Other trilobites responded to predation by becoming harder to swallow. Species such as Parapelechia evolved sweeping defensive spines projecting from their shells in multiple directions. Fossils from Morocco's famous Fezouata Formation preserve incredibly delicate antennae alongside these intimidating genal spines. Such elaborate defenses were likely responses to the growing threat posed by Ordovician predators, particularly cephalopods equipped with powerful grasping tentacles and crushing beaks. In a world where being seized or swallowed was a constant danger, a body covered in sharp projections could turn a trilobite into a dangerous meal. If Parapelechia suggests defensive escalation, Selenopeltis pushes that strategy even further. This bizarre trilobite was surrounded by long-curved pleural spines radiating outward, like the ribs of an alien crown. The entire animal resembled a living caltrop. These structures probably served several functions at once, stabilizing the body on soft mud, while also making it extremely difficult for predators to swallow. Every part of its outline increased the cost of attack. Chirurus was a trilobite whose armor transformed it into something resembling a medieval weapon. Its deeply segmented body culminated in a tail shield armed with long, backward-pointing spikes, almost like a sharpened pitchfork. Combined with facial spines and thickened armor plates, this allowed the animal to curl into a nearly impenetrable spiked ball whenever threatened. To a predator attempting an attack, Chirurus would have become a mouthful of blades. Not all Ordovician trilobites survived through defense alone. Some became large enough to dominate the seafloor by sheer scale. Isotylus rex, discovered in late Ordovician rocks of Manitoba, Canada, remains the largest trilobite ever found. A complete specimen measures an astonishing 72 centimeters in length, nearly the size of a small dog. Unlike heavily spined species, Isotylus relied on mass, breadth, and a smooth armored body. Its heavy shell likely allowed it to plow through sediment while resisting attacks from giant predatory cephalopods nearby. Encountering such a colossal trilobite crawling across the Ordovician seabed must have been a surreal sight. Others turned their armor and mouthparts toward active feeding. One extraordinary example is Bohemolichus incola, a heavily built lichid trilobite covered in bumps, sensory nodes, and stout defensive spines. Recently, advanced synchrotron imaging revealed fossilized gut contents inside one specimen, offering a rare direct glimpse into its diet. The evidence showed that Bohemolichus consumed thin-shelled animals, such as bivalves and echinoderms. It was not merely armored for defense, it was also a shell-crushing predator, using its reinforced front end to break and process hard prey. The Ordovician Trilobites were not strange by accident. Their bodies record a world where the seafloor had become dangerous, crowded, and competitive. Eyes rose above the mud. Head shields widened into sensory platforms. Shells became spikes, blades, and armor. Long before vertebrates dominated the oceans, trilobites had already turned survival into some of the most extreme anatomies in the history of arthropods.